Hey, Geometry. Chapter 7, Lesson 4, we got properties of special parallelograms right now. Okay, this is a very special lesson because we got special parallelograms. The special parallelograms are the rectangles, rhombuses, and squares. So there's the answer to the question. Is it rhombuses or rhombi? They said rhombuses here. So all of these are special parallelograms. Every property that applies to a parallelogram will also apply to these. Okay, so remember, for all three of these, opposite sides are going to be parallel and congruent. Opposite angles are going to be congruent. And the diagonals are going to bisect each other. So those are properties that are true for all parallelograms. So they're going to be true for the special parallelograms of rectangles, rhombuses, and squares as well, plus some additional things. Now keep in mind that a square is the joining of a rectangle and a rhombus. We're going to see that here in a little bit. Okay, rectangles, have 4 right angles. Okay, rhombuses just have to have 4 congruent sides. You put those together, okay, they get married, they will have a square for a child. Okay. Now 7.3, let's go jump over to 212. So here's our definitions here. We have a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. So they're all parallelograms. A square is a parallelogram with 4 congruent sides and 4 right angles. So this is the both characteristics of a rhombus and a rectangle. Okay? So a square is a rhombus, a square is a rectangle, but rectangles are not rhombuses. Okay? So a square is always a rectangle and a rhombus. A rhombus is sometimes a square. So if the rhombus has 4 right angles, then it's a square. A rectangle is also said to be sometimes a square. So if a rectangle has 4 congruent sides, then it's going to be a rectangle, or then it's going to be a square. Okay, so here's all the different pieces that we have going on here. We have a bunch of corollaries. Remember, corollaries aren't things you necessarily prove. And we get to some theorems here on page 213. So corollary 7.2, a quadrilateral is a rhombus if and only it has 4 congruent sides. You already know that. Okay? This one also includes squares. So a square has to have 4 congruent sides. A quadrilateral is a rectangle if and only if it has 4 right angles. So this one also includes squares. Those are kind of the no-brainers that we've been talking about a lot here. Let's go on to page 213. Here's your square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay, so it has to be both things, rhombus and a rectangle. Okay. Here we get into the diagonals, and that's what's going to be a little bit new with these. 7.11, rhombus diagonals theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Remember, it means they form a 90-degree angle. So if the diagonals of a rhombus are going to form 90-degree angles, we can also say the diagonals of a square will form 90-degree angles. So they will be perpendicular as well. Okay, the diagonals of a square, since it applies to rhombuses, it's going to apply to squares. Rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So this is a parallelogram, so we know opposite angles are congruent. Now, for a rhombus, and consequently a square, the diagonals will bisect opposite angles. So we can say the diagonals of a square bisect opposite angles. So the diagonals of a square, some angels, I did it, I spelled angels. Diagonals of a square bisect opposite angles. Now for a square, if you bisect opposite angles, they're going to form 45-degree angles. Okay? They're going to form 45-degree angles. So those are the things that are true for a rhombus. Okay? And consequently, they'll be true for a square as well. They're perpendicular, and they bisect opposite angles. Now, there's also parallelograms, so we know they bisect each other as well. A rectangle, diagonal theorem, a parallelogram is a rectangle if and only if its diagonals are congruent. Okay? So the diagonals, the entire length is going to be the same here. So the diagonals of a square are also the same length. Diagonals of a square are also going to be the same length. This is very helpful in construction, knowing that the diagonals are congruent. It's used a lot of times to test if you have a 90-degree angle. Okay, hang on, I got a picture here from the textbook. I used this when I was making a sandbox. Making a sandbox for my kids. I wanted it to be square. Not that it's super important, but anytime you have a rectangle or a square shape and you want to make sure you have 90-degree angles, you measure the diagonals. And if the diagonals are the same length, then you know you have 90-degree angles because the diagonals of a rectangle or a square are going to be the same length. Okay. So let's go back to these definitions, and we're going to write underneath some of those things about the diagonals here. So we have all our definitions in the same place here. So rhombus, parallelogram with four congruent sides. The diagonals are perpendicular, upside down T, that stands for perpendicular. If you need to write it out, write it out. And bisect opposite angles. Okay? So for a rhombus, the diagonals are perpendicular and they bisect opposite angles. For a rectangle, we say diagonals are congruent. That means they are the same length. Diagonals are congruent, same length. A square is a parallelogram with four congruent sides. So here the diagonals, they're perpendicular, congruent, and they bisect the angles. Uh-oh, blue's running out. So for a square, it does all three things: perpendicular, congruent, and bisect the angles. Okay, let's go look at our practice problems. For any rhombus MNOP, page 214, any rhombus MNOP, decide whether the statement MO is congruent to NP is always or sometimes true. Draw a diagram and explain your reasoning. So we have a rhombus. Ooh, not drawn very well. There we go, a little better. MNOP. So I just start in a corner, go around. They want to know the statement MO is congruent to NP. Okay? Is that statement always or sometimes true? So are the diagonals congruent? So are the diagonals congruent? Well, in just a rhombus, no. But if the rhombus becomes a square, then it would be. So we would say sometimes, and our explanation is the rhombus could be a square. Okay, they didn't give us the most specific word. They just said it's a rhombus. Kind of like saying we just have a quadrilateral. There's lots of different types of quadrilaterals. Okay, for any rectangle PQRS, decide whether the statement angle PQS is congruent to angle RSQ is always or sometimes true. Draw a diagram. Explain your reasoning. PQRS. They want the statement PQS. So PQS, so I have to draw this diagonal. So this angle here is congruent to RSQ. Okay, is that always or sometimes true? So if I look at those two angles, here's one angle, there's the other angle. You see the Z that's being formed? We have a rectangle, which means the top is parallel to the bottom. So these are alternate interior angles. So this will be an always true. They're alternate interior angles. Exercise 3 through 5. The diagonals of a rhombus ABCD intersect at E, given that the measure of angle BCA equals 44 degrees. Got it? AB is 9. Got it? And AE is 7. Got it. Find the indicated measure. They want us to find the measure of BC. Well, BC is a side. We have a rhombus, which means we have 4 congruent sides. So if AB is 9, BC also has to equal 9. Okay, we have 4 congruent sides. AC. AC is a diagonal. We know in a parallelogram, diagonals have to bisect each other. That means 7 is half of it. So AC has to be 14. Diagonals bisect, or E is a midpoint. Measure of angle ADC. ADC. So they want this angle right here. What is that angle right there? So if we knew opposite angles, it'd be equal to that. This is the only one we know. This is 44. Since we have a rhombus, we know that this diagonal has to bisect this angle. Okay? For rhombuses and squares, they bisect the angle. So this is going to be 44 degrees right here. So altogether, that is 88. So if I take 180 minus 88, consecutive angles in a parallelogram will be supplementary. So 180 minus 88 gives me 92 degrees. That would be the measure of the angle. Okay? See if you can get these answers before I say it. Exercise 6 through 8. Do the diagonals of rectangle EFGH intersect at I, given that the measure of angle HFG equals 31 degrees and EG equals 17. EG equals 17. Okay, they didn't label that. So this whole thing here is 17. Oops. Find the indicated measure. Measure of angle FHG. FHG. Okay, so we have a rectangle. That means we have 90 degrees here. So if this is 31, this has to be the complement to 31 degrees. So if I take 90 minus 31, I'm going to get 59 degrees. So it has to be 59 degrees right there. Okay, you can use the triangle. It would be the easiest way. 90 minus 31 because there's already a 90 degree angle there. HF. HF is the other diagonal. Well, in a rectangle, diagonals are congruent. So that makes HF the same length as EG. That's going to be 17. That's because we have congruent diagonals. 8, measure angle EFH. 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 It's going to be the complement to 31. So that's going to be 59 degrees again, alternate interior angles to down there. Complementary 31. Last set, and I have one more question on another piece of notes. And then the assignment, there's quite a few questions in this assignment, just a lot of practice with knowing what kind of shape you have, what are the diagonals going to do, and quite a bit of application that can happen with this as well. So exercise 9 through 11, the diagonals of square LMNP intersect at K. Given that MK equals a half, MK is equal to half, find the indicated measure. So we have a square. They want PK. PK, well, the diagonals bisect each other, so that's going to be a half, because the diagonals bisect. Measure of angle PKN. PKN. So that's a intersection of the diagonals, and the diagonals in a rhombus and a square are going to be perpendicular. That's going to be 90 degrees. Measure of angle MNK. MNK. They want this angle down here. The diagonal has to bisect the 90-degree angle. We said that was 45 degrees. Okay, so those three answers. The final thing, final example I'm going to do, let's say you have rectangle QRST, find the length of the diagonals. So QS is 5x minus 31, RT is 2x plus 11. So we draw our shape just to see what we have here, QRST. So QS is 5x minus 31, and then RT is 2x plus 11. So you see they gave us the two lengths of the diagonals. Two lengths of the diagonals. In a rectangle, the diagonals have to be congruent, so we will say 5x minus 31 equals 2x plus 11, minus 3x over, so 2x minus 31 equals 11. 31, so 2x equals 42. We get x equals 21. Is that fast? Woo. Lightning fast? Some of you had it before me. X equals 21. Go up, put it back in there, because they want the length. They don't want the answer of x. They want the length. So what's 5 times 21 minus 31? So that'd be 105 minus 31 would be 74. So that's QS. And then we have 2 times 21 plus 11. So that's 42 plus 11, that is 53. Something's not right. Why did I subtract 3x? Some of you are probably yelling at me right now for that. Why did I subtract 3x? That was the answer. It's supposed to be a 3x. I need to subtract 2x. That's why I checked my work. Something was not happening here. Those should be the same. This should be 3x. 3x equals 42. So x is not going to be 21. X is going to be 42 divided by 3, which is 14, I believe. Yeah. So let's try that. 5 times 14 minus 31. That'd be 50, 60, 70 minus 31. It would be 39. 2 times 14 plus 11. That's 28 plus 11, so that's 39. So they're both 39, length of 39. There we go. We got it. Sometimes I make mistakes too. We just go back and try to fix what we did and keep moving from there. So that's it for this lesson. Again, there's probably going to be quite a few questions over this, but remember the properties and keep those definitions handy and what the relationships are for all those diagonals, and you should be all right. See you in class.